Hello everyone. I'm just going to be doing some game dev today, and I'm just gonna be recording the process. Initially I wanted to do a live stream, but I'm still getting some stuff sorted, so it's gonna be pre-recorded and uploaded to the channel. This is not really a tutorial, it's just me creating this new project essentially, and kind of doing it in a way that is a little bit more public, essentially. This is based on some tests and things I've done before. So the idea is to create some sort of 2D isometric kind of scene for now. And there's a few resources I've been able to go over recently, and I made some tests as well. Now the first thing I noticed is I discovered there's actually something we can do instead of scaling manually this project. By the way, if you missed the setup, I recommend you watch the setup video where I get to this point. So we have this project with this little object here, but I implemented this mechanic which used the DPI scaling of windows to render the object bigger in a window that is scaled in high DPI. So you can see that there's these flags there, true, but I don't need them anymore, so I'm just gonna remove all of that stuff. Don't need it. Because I discovered there's a hint that you can use. So now let me just verify how it's called. This one. Like that. And now all the elements will be DPI scaled, including the window, which is really neat. So I didn't even know about that, and I'm kind of blown away because I was doing it all manually before without realizing how silly that was. So yeah, pretty glad about this change. We're gonna set up some basic stuff for the window. So I don't know why I put maximize there. Resizable. I think I can make it pretty big. I'm just trying it on another display right next to me. Okay, cool. Resizable means that you can change the size, so that's really neat. And the project I'm gonna make isn't gonna use any scaling of the pixels, so you can see that it's just staying like that, right? I don't want to make the pixels bigger or smaller, I just want to keep them exactly like that. This is just a test component that we, test entity that we created. I'm gonna try to create a prefab for like representing a game tile, I think. Let me just verify I forgot how to do this. Okay, yeah, there we go. I'm gonna create a new function. Create the prefabs. we're going to pass the ECS. So it's gonna be like that. We init the ECS, we init the components, init the tags, and then we create the prefabs. So the first prefab is going to be, we're going to make a new entity with the ECS, and the name is going to be, this is going to be a cell, a game cell. So the way that the game is going to be rendered is there's going to be like potentially hundreds of thousands of tiles, but then only a subset of these are going to be rendered in the cells on screens. So what I'm doing now is just creating a new kind of prefab, so an object that we can kind of instantiate. So that's how you do this. New prefab cell with the tag ECS prefab to make it a prefab. So the prefab, we're gonna have a box component for it, which is gonna be the box. It's gonna be created with ensure. Then with the box, we're gonna be able to set up some stuff. So let's just set up the box, its bounds, because we know the bounds are always gonna be the same. The position that's gonna change for each cell. So the bounds of the box, let's say they should be maybe, well, maybe we should define some field for that, like, oops, my bad. We should define some stuff, or we could also use a constant, a global constant. So let's define, this is gonna be the cell width. Going to be equal to 64. It should be a floating point number, I think. And then the cell height, same thing. And these are going to go, one tab I really need is structure. I really like this. It's one of the main reasons I like this C99 software. So, yeah, cell width, cell height are going to be the bounds. Also, for color, let's just say it's going to be yellow. So we create the prefab. This was just a test. We could literally remove it for now. It would just make it so that nothing is drawn in the window, nothing would like break down. And then I'm gonna have another function to create the cells, the actual cells. And I think I need my ECS. This is going to be a case for almost every function. And in fact, eventually we'll use a system called the mains callbacks, which is going to make it so that we share the ECS through SDL's main callbacks as well. We'll get to this point. I'm not explaining anything, but it's because I need to focus on my own project. So if you have questions, just ask them in the comments, and I'll be able to help you out. So here we want to create the cells. This is going to be I just need to re-verify the documentation how to create. Alright, there we go. So we want to, just for the sake of it, we're just going to try to create like a few cells in a row. So let's make a for loop. Let's create 5 cells. So the way we are going to create a cell is it's going to be the new cell we're creating, and we have to use a new W pair with the ECS. Then we use ECS is A, and then we essentially look up the name of our prefab, which is called cell. So this is a new instance of cell, essentially. And now this new cell, I'm going to, so we added a box here, so I can get that box with I have to create a pointer to a box, and then I can use ECS get like this, and if I want to be able to modify it, it's get mutable, get mute. Then the position on the x-axis is going to be equal to I multiplied by the width of the cell. Like this. So this will create 5 cells one by one next to each other. They should already be appearing on the screen if we just create the cells. But we also need, because for them to appear on the screen, they also need to have a tag for draw. They need to have this pair between 2 tags, draw batch and screen, which are here. And I did not assign this, so I think I'll just, for now, I'll remove this. It's a little bit oops, I didn't remove it correctly. Like that. And I think I'm going to rename this. It's going to be draw cells, or it's very generic right now, so it just draws all the boxes. Let's just name it for what it does. This, we don't need it anymore. It's an old call for when we were manually doing all the scaling. Alright, so we have all the boxes. Now they're drawn from their center, so we're gonna change that actually directly in the box constructor, which is this. Drawn from center will be false. There we go. Let's create the component. And this one will be to render a sprite. And all we have to do really, I think, is keep... I think we could use the sprite atlas that I already demonstrated before. So we can essentially just keep a name, you know. So this is going to add a sprite to draw. I think we might want to maybe if we were to kind of extract the origin as its own component. So they're both using this origin. Then we just need, let's copy this. This is going to be the constructor of for an origin. Origin. Here, to draw a box, we'll need the box itself, and we'll need the origin. Like that. Creating the cells, same thing. We'll need. Here we'll just get the origin essentially. We need to define it. It's not a big deal. Like this. And here as well. Also in the main function, let's create the function for creating all the systems. It's going to be a little bit more clean. And this system will also need to take the origin. So now there wouldn't be any difference with the project. Oh, origin is null. That's because in the prefab here I did not add any origin, so we don't really need to get it though, so we could just use add essentially. Oh yeah, we got another error. That error is because this here it needs to be index 1 that we get. Alright, so we're back. But now we've kind of extracted the origin as its own component, so the sprite can also use it. And I'm going to create a function to draw all the sprites for now. We're going to get the sprite component, and I didn't name the parameter. We're gonna get the origin, like that. Then do a for loop. So really the function we need to use, I showed it in the, I didn't show it actually. It's a function from the sprite atlas. We can use render entry to do this. We need to provide the atlas. We need to provide a name, so we could use this string CTE, and then we could use sprite name. Can we? Then we need to use a destination rectangle. So let's just create a new rectangle for the destination. For now, I'm going to use the origin, position X, origin position Y, and since I already know that it's the cell, I'm gonna use cell width and cell height, but I'm gonna try to make it so I can, instead of being a box component, I'm gonna make a bounds component, and the box will be a visualization of the bounds, so the sprites can use the bounds as well to know where to draw itself. Something like that maybe. So we're gonna render at the destination. We need a pointer to that, sorry. And the tint, that's just white. Like this. Draw sprites. If we go down there, I can use the short syntax, I think. So ECS, this is going to be system draw sprite, ECS on update, then we need to use a sprite component and origin for now. In the prefab, I'm gonna get the sprite. I'll need to declare these components property here. And then the name, in that case, I'm gonna go get an art that I have, an external file that I already have. So give me a second. Alright, so let's use this first tile here. Let's bring it in the data. Let's paste it like that. So I have this first tile. It's 64 by 64. I drew it. It's just a temporary test tile, and it's called T underscore tile underscore green 0 PNG. So we're going to give it that name. Also, something to take into account is that we should make sure, we are loading this folder dat. So we're loading all the sprites for now, but for the sprite to be copied into the build directory, we need to reload the CMake. So it's gonna take a second, just copying the sprite. You could also bring it manually, but if you have a lot, it's gonna be faster. There's an error. Oh, I can't do it like this. So instead, what I have to do is I have to create a new string. Then I'm gonna init the string. Like that. Then I'm gonna pass the string. And then I'm going to clear the memory of the string. Like this. Alright, there we go. We have 5 sprites now. So we should... this is going to get laggy as well, because at this point we're just going to kind of brute force the render. And I want to do some profiling of that. I already have all the function for the profiling, so it's actually pretty fast. Just gonna double check. Yeah, okay, so I have a module in my depth here called profiling, and I already have a bunch of function there which I could use to measure the frame rates. So the way I can do this is during the while loop, I'm gonna at the start I'm gonna use profiling start like that, and we need to include profiling like that. Also, we'll need to create a frame data. Like that. We can just do it like this, I think. and then maybe right here, maybe, or maybe here. We could do frame equal there. We could do this, and then when we profile, we could just use the frame to save all the info. I'm gonna rename it frame data. So you do everything, and then here after the rendering, I'm gonna do profiling count tick. I could probably actually like it's weird that, oh, there was a typo. Oh, it was date. My god, I couldn't see it. It won't be a long video because I have some errands to run, but and I'm a bit tired. But hopefully you pick up a few things. I did it again. So yeah, you can do something like this. Now I would probably need to group these two calls together or something. Then you can get the FPS after you gathered all the frame. You calculated the time, you know, my point is. And what we're gonna do is we're gonna set the frame rate in the window. So we're gonna do a temporary string. I like this because you can enable it with printf. So we could do something like FPS and then do 0.1f to have a only one decimal point float number, and then we can set the window title. And then just I'm gonna use string get c string like that, and then don't forget to clear the string. Alright, so this will show us the frame rate there. Now it's very high, extremely high, because the application is not vsync. I should probably change that. Let me just verify how I used to do it. Alright, so I think after we create the renderer, we want to set the renderer vsync to be true. And also another thing that we should probably do is tell the app to run with Vulkan. And I like to also add the other int, which is the GPU debugging int. So now you can see the frame rate is capped at the frame of the display. So yeah. It was running at 15,000s before. It's a beefy computer. Right, so now instead of spawning the tiles in the fashion that we are spawning them, which is determined by here, this create cells. Sorry, I thought I was gonna sneeze, so I cut off the microphone. It's probably gonna happen in 1 second. Alright, never mind. So yeah, instead of just creating 5 cells like this, we're going to essentially kind of create a bunch of cells in a configuration that is a little bit different. So I'm gonna generate, the way I'm gonna do it is, I'm not sure it's gonna work exactly for the first try, but I'm gonna have a size which is gonna be 56, which is gonna be a big size of an arena. But for the demonstration, I'm gonna start with a smaller size of like 12. Then I'm gonna have not one loop, but 2 loops, one into the other. And the second loop will be J. And in the case of the first loop, we're gonna go from 0 to the size. And in the case of the second loop, we're gonna start from the size and we're gonna continue until 0. Like this. We need a small function that will basically it will take, so when you deal with an isometric game like this one, the full art is 64 by 64, but there is only a smaller area, right, which is the walkable isometric tile, and in this case it's 32 by 34 that I'm using these metrics. Sorry, 64 by 34. These are the metrics of the isometric section of the tile. So I'm gonna encode this information here. I'm gonna say that the ISO surface width is 64 and the height is 34, which is the big one. And then also, let's just say the stage size is the value we'll be using. So here is the stage size that we're using. And we're gonna have a little function, which is gonna be basically a function that we can provide it to a column in a row, and then it kind of produces the pixels, the position on the screen for this isometric column and row. All right, so can have another static for now, and then we can say this is going to be the ISO to world conversion. So first of all, it takes ISO coordinates, and then it returns, it takes a pointer to world coordinates, and it returns these. Not like this. So this is the result. And then at the end we return it. Actually, that's not at all what we're supposed to be doing. So this is the result, and then we're gonna dereference the out pointer and then put the... I don't think we can do that. Oh yeah, we can. So the x, let me check the formula. So the x is going to be the x is going to be the iso coordinate x multiplied by the iso surface width divided by 2 plus the iso coordinate y multiplied by the iso surface width divided by 2. And then the y is the iso coordinate y multiplied by the iso surface height divided by 2 minus the iso coordinate x multiplied by the iso surface h divided by 2. So we're looping over all of these, and then we have an origin here. And what we do is we use iso to world. Then we construct a new point ij. And then we return, we pass a pointer to origin position, which is going to get updated by with these here. These need to be converted to a float. And there's a bunch of redundant parentheses apparently, so let's remove. There we go. Now the order is wrong. We'll check out why, and also you can see that it's like a little bit offset. I wonder if this should be inverted a bit. Oh yeah, this was the problem. I wonder if we keep it in this order, could we start from 0? Go to the end of the stage. No, doesn't work. Okay, so let's keep our formula since it works. And let's put J and I. So now we can see that these we can see that there's a little problem, which is that the stage has a certain height, and we need to offset by half of that height, right? So what we need to do is we need to take the origin position y, and we need to increase the position by it's gonna be the stage size divided by 2 multiplied by the isosurface H. So this is going to bring it into the screen like that, which is neat. If we increase the stage, we wanted 56. It looks really, really big, but it still renders really fast, which is what I was wondering about. So I'm going to use a cutoff value. Stage cutoff. This is gonna be 26, and I don't think it needs to be up here, because here in create cells I'm gonna have the value. So I'm gonna skip creating a new cell if a certain calculation compared to the cutoff value gives certain true or false result, essentially. So the way I want to think about it is I'm gonna do I minus j is less than the stage cutoff, and this is going to essentially lead to a continue, which is you skip that tile. Just view what it looks like. Oh, we don't have anything anymore. Oh yeah, I made a mistake. It's not less than the stage cutoff, it's less than the stage size minus the stage cutoff. Sorry, I misread my stuff, but it still doesn't work. It might be the, again, j minus I thing. Alright, cool. I mean, I cut a little bit too much. Let me see. I feel like my formulas are going to be a little bit off. Okay, I messed up somewhere. First things first, I'm gonna change this for J. And this here, I'll change it for I. Like that. And I realize what I'm doing wrong now is that I was kind of like reversing the, it shouldn't be, the case shouldn't continue, it should be the opposite. So I'm gonna try different things just to so create a boolean called out of bound, and it's gonna be I minus j is less than the stage size minus the stage cutoff, like that. And then if b, so it's going to be greater or equal. And then if we're out of bound, we're going to continue. All right. So we can see what's happening. It's cutting off from the top 20, a certain amount of rows. I don't know if it's 26 or 13. I need to verify actually. So this is out of top bound. So let's make another out of bound, because I don't remember in my notes I didn't note what each case does. So we have this one now, this next case. So if it's that or this one, which we haven't identified yet because my notes are out of order. Okay, so this is the left case there. Out of left bound. Like this. Alright, so because we were cutting off some tiles, there's like an offset now that we need to apply here to the position. So the origin position X will be offset by the stage cutoff times basically half of the isosurface width. And then the origin position Y, same thing, stage cutoff times isosurface H divided by 2. And then this needs to be floatified if we want. Actually, this should be like that, and then we should float it. Yes, I know we lose precision. That's okay. That's what we want. But actually, maybe to avoid this annoying warning, maybe we float and then we just do a round. And that would be the Alright, so you can see everything moved a little bit offset now. We just need to calculate the other two boundaries. So the next one, I believe, is going to be the bottom boundary. This is j minus I is greater or equal to the stage size minus the stage cutoff. And then if he exceeds the bottom bound, out of bottom bound, we're gonna do it like this. Now you can see it cuts at the bottom, and we just need to cut to the left as well. The right, sorry, right bound. So the right boundary is I plus j is equal to, is greater or equal to the stage size multiplied by 2 minus the cutoff for some reason. Like that. There we go. Now things are a little bit off, so I think I need to cut one more. I wonder, the bottom bound, I think I want to get like kind of a different kind of style in the corner, and it's not rendering exactly like I imagine. Like the bottom corner gets cut, so I'm gonna have to look into it. So I think I'm just gonna rework the formula a little bit. I probably messed up. I'm gonna put, okay, so instead of out of, I'm gonna say this is in in, so it's going to be greater. Also, why do I have ligature? I hate that shit. I don't understand. Whoever invented that, whatever. Never coded in his life. It's the most annoying thing I've ever seen. Oh, I messed up. Oh yeah, because now basically it has to be the case for you to do this. Oh, also it has to be all of these now, not the or, but and. Alright, it still gives the same result. I imagine so it's the bottom boundary that's not working, and it's also the only one that is inverted like that. If I set it like this, I minus j, okay, I need to think about it a little bit more. Let me take taking my pen. So the way that the coordinate system works is this is x, and then this is y, or I guess sometimes we call it z, I think. But I call it y for some reason. You could also say this is the row, and this is the column. So what I want basically is I want to take a map that's like this, and I want to say only render things that are in this, within these four boundaries, creating a square out of the rendering essentially. So I wonder if we should just like reconvert it to a pixel coordinates. If I cut one more, oh, now it looks exactly like how I imagined. It might just have been the numbers, the way they lined up, because this is exactly the display that I want. I want 2 on each corner. This is gonna be a nice way to make a kind of a tactical arena. So that works great. There was just a, I don't know, I looked for a while for no reason. We're gonna create the system a bit differently. Like this, I think. Alright, so we're having a nice result. You can see it's a little bit messy right now, but we have like kind of this display. It doesn't scale, so if you crop, you won't see all of it. So I'm gonna have a moving camera system where you can present the display in a like always centered manner, so that depending on your resolution, you just see less tiles and you have a moving camera to fill in the rest. So I think I'm gonna take a break at this point. This is a nice little point to stop. We figured out how to render this thing, and now there's a lot of problem with displaying something in 2D isometric, so I'll need to do a lot of thinking, but hopefully we can figure things out. I don't want the game to be visually too complex as well. Actually, I just want to try one last thing. I'm gonna just show you how quickly I can change the image. I'm gonna disable, I think I'm gonna disable the box for now. So just here I'll disable the system for a sec. And I'm gonna take another art that I made, bring it in my data, add it. We're gonna rerun the CMake, and then we're gonna just change the tile name here. Instead of green, I'm gonna use barren 0. And I think as simple as that, we should have the new display with the different tile set. There we go. So it's going to be very useful. By the way, if you want my tools, just watch the setup video where I provide everything. I think what I want now is to like put more. I want to try to put one entity for each tile, like really fill everything and see the performance I'm getting on different devices before I analyze how much kind of, if I need to create like batches of sprites or pre-render something to a target or stuff like that. So I'm just gonna kind of fill with even more stuff next time and see what kind of performance I'm getting. Last thing to do is to commit your change. So we're gonna say we render. This is the rendering the game cells. First attempt. Alright, and that was a success. So yeah, that's gonna be the end of the video, and thank you for tuning in. I'll try to post and possibly even do some streams, and just need to get into the mindset of doing that, and having people kind of follow along might be a little bit daunting, but I think I'll get to it. So have a good day, everyone.